Hello and welcome to We Love Anatomy. Today we are going to learn about the different types of fractures and how our bones repair themselves after injury. There are two classifications of fracture that do not pertain to how the bone is broken. This image demonstrates a closed fracture, meaning that the fractured bone is contained within the skin. You can see here that the bone is still contained within the skin of the thigh. This image shows an open fracture. The difference here is that the lower bone fragment is penetrating outside the skin of the thigh. You can see that here, and if you were to come upon somebody with this injury, you would be able to visibly see their bone with the naked eye. This image shows a transverse fracture. This type of fracture occurs when the break is at a 90-degree angle to the shaft of the bone, which you can see here. The shaft goes this direction and the break goes that direction. So it's a perpendicular break. Here we have a spiral fracture. Spiral fractures typically occur due to injuries that involve twisting of the bone. The fracture is then like a corkscrew that coils around the bone. You can see it in this drawing here, and then compare it to the spiral fracture of the humerus. A comminuted fracture is a severe break that results in several bone fragments. This radiograph shows a comminuted fracture of the distal tibia, resulting in multiple fragments, which you can see right here. You can also see a transverse fracture of the distal fibula. Green stick fractures are most common in children due to the relative flexibility of their bones. These are partial breaks where only one side of the bone fractures, as you can see in this drawing here, and in this radiograph with green stick fractures of both the distal radius and ulna. An impacted fracture occurs when there is a compressive force to the bone. The bone breaks and then one fragment is driven into the other fragment. This would result in a slight shortening of the overall length of the bone. An oblique fracture is a straight fracture that occurs at an angle other than 90 degrees. Therefore, it is not perpendicular to the shaft of the bone like the transverse fracture. These differ from spiral fractures because they are not like a corkscrew. Here's a quick recap of our fracture types. A transverse fracture is straight across the long axis of the bone, perpendicular to the shaft. An oblique fracture occurs at an angle other than 90 degrees to the shaft. A spiral fracture is like a corkscrew fracture from a twisting injury. A comminuted fracture results in several bone fragments. An impacted fracture drives one end of the break into the other. And a green stick fracture is a partial fracture where only one side of the bone breaks. Last, an open fracture or compound fracture results in the bone protruding out of the skin, while a closed or simple fracture leaves the bone remnants contained within the intact skin. When a bone breaks, blood vessels are disrupted and they bleed. Over the first 6 to 8 hours, a fracture hematoma or blood clot forms. Without blood flow, the bone cells around the fracture begin to die. You can see the hematoma formation and broken blood vessels on the left here in image A. Within about 48 hours, chondrocytes from the endosteum begin to produce cartilage and create an internal callus between the two ends of the bone, which helps to stabilize the bones. At the same time, the chondrocytes and osteoblasts from the periosteum begin to secrete an external callus made of hyaline cartilage and bone. You can see this in image B. So we have the external callus here and the internal callus in the center there. Notice that the callus is larger than the circumference of the bone. It will slowly decrease in size while the bone is repairing. Over the next several weeks, osteoclasts work to resorb the dead bone. Osteogenic cells differentiate into osteoblasts, which then work to build new trabecular bone, which will replace the cartilage that was created during callus formation. You can see that in image C, where we have this new trabecular bone in the center, uniting those two fractured ends. Over time, the internal and external calluses unite. Compact bone replaces the spongy bone at the outer margins of the fracture, and the repair is complete. Image D shows the healed fracture, which will most often return to its original size and shape, though sometimes a small enlargement will remain. So in image D, you can see this compact bone on the outside here, and then this trabecular bone in the center. And then in this healed bone, you can still see that slight enlargement where that bone was healing, but over time, like I said, that might go back down to its normal size. In this image, you can see a displaced humeral fracture. This milky looking material that you can see around the fractured ends is the formation of the callus. The callus formation can actually help us diagnose fractures that are otherwise hard to see. If there is no fracture seen upon an initial X-ray, a repeat image in 1 to 2 weeks might show the callus formation, which would indicate that hidden fracture. Thanks for watching our video on fracture types and bone repair. We'll see you next time.